In this tutorial, we will talk about left shift and right shift operators. So which means what will be the output if we left shift a number by n or if we right shift a number by n. N is the numbers of times we are shifting a number. So in order to get a clear picture, I have taken two values. The first one is a. A will be the actual number and n will be the number of times we are shifting a. So I have taken 10 and 2. I'll be shifting 10 two times. So firstly, I'll left shift 10 two times and then I'll right shift 10 two times. Let's see what will be the output. So as you can clearly see over here, if we left shift 10 two times, we will get 40. And if we left shift the same number two times again, we will get 2. Let me change the digits over here. Let me keep it 40 and let me shift it 4 times. So now, if you can see the output over here, if we are shifting 20 towards left 4 times, we will get 320. And if we are right shifting 24 times, we will get 1. So let's understand how it's working behind the scene. Okay, so I have already taken the numbers over here. So before understanding the working of shift operator, we must know how can we convert a number into binaries. So for example, we have 10 and we have to convert into binaries. So we have two different ways to convert a number into binaries. The first one will be very simple. You must have learned it during your school classes. So what we will do to convert a number into binaries, we will keep dividing the number until we get remainder either 0 or 1. So what I'll do, I'll keep dividing 10 by 2. So 5 twos are 10. I'll get remainder as 0. Again, I'll keep dividing the divisor by 2. 2 twos are 4. Remainder is 1. Again, divide by 2. 2 ones are 2 and remainder is 0. So now finally we have 1 over here. And so if you go from bottom to top, all these reminders 1 0 1 0. So this is the binary conversion of the 10. Similarly, you can do for the other numbers as well. So if I'll take 20, so what I'll have to do, just keep 20 over here and you have to divide it by 2 and you will get 0 over here. So similarly, binary conversion of 20 will be 1 0 1 0 0. So this is the binary conversion of 20. So this is the one way of converting a number into binaries. So let's talk about the another way. So in the second approach, what you will do, since we are converting the number into binaries, so I'm taking the size as 8 bits. So if you can see over here, 1 2 3 4 5 6 7 and 8. So let me write the actual numbers as well. Anything raised to the power 0 is always 1. 2 raised to the power 1 is 2. 2 raised to the power 2 is 4. 2 raised to the power 3 is 8, 16, 32, 64 and 128. So how can we convert this 10 into binaries? Binaries means in the form of zeros and ones. So firstly we will see if 128 is less than 10. So if it is less than 10, we'll keep it. Otherwise, if it's greater than 10, means the value is greater than 10 and we will mark it by 0. So we will move on. We will see if 64 is less than 10. No, it's not less than 10. We will mark it by 0. We will move on. Same for 32. Same for 16. Now we will see if 8 is less than 10. Yes, 8 is less than 10. Then we will mark it by 1. So now we have got 8. So 10 minus 8 is 2. So means we need two more numbers to get 10. So as we can clearly see, 2 raised to the power 1 is 2. So we will mark it by 1. So we have 8 and 2, which means 8 plus 2 is equal to 16, and rest of the numbers will be marked by 0. So that means 1 0 1 0. 1 0 1 0 is the binary representation for 10. So let's do it for 20 as well. So 128 is less than 20? No, it's not. Mark it by 0. 64, it's not less than 20. Mark it by 0. 32 is also not less than 20. So 16 is less than 20? Yes, it is. So what we will do? We will mark it by 1. So now out of 20 we got 16. So we still need 4. Where can we get the 4 from? Here we have. So just mark it by 1. So rest all is 0. So if you can see over here, so 16 plus 4 is 20. So the binary for 20 will be 1 0 1 0 0. So it will be 1 0 1 0 0. So since we got the understanding of converting a number into binaries, so let's understand the left shift operator first. I'll take a number as 10, and then we'll try to shift its bits one by one. So binary conversion of 10 is 1 0 1 0. Since I have taken 8 bits over here, so rest of the bits will be replaced by 0. So now what we are doing, I'm going to shift this A, which is 10, towards left by 1. By 1 means all these bits will be moved towards left. So first bit, we are not getting anything over here, will be replaced by 0, and this 0 will be moved over here. This 1 will be shifted over here. This 0 will be shifted over here. This 1 will be shifted over here. This 0 will be shifted over here. This 0 will be shifted over here, and this over here, which means we have shifted all the bits towards left by 1. And the last, it will go out of space, so we are not going to worry about the last bit. As you can see, this is over 10, and if we see over here, this one, it's 2 raised to the power 4, which is 16, and this is 2 raised to the power 2, which is 4. So 16 plus 4 will be equal to 20. So now if we again going to shift 10 by 2 towards left, what will we get? This 0 will be moved over here. Since we don't have anything over here, replace it by 0. This 0 will be moved over here. This 1 will come over here. This 0 here, 1 here, 0, 0. So now over here, this is 2 raised to the power 5, which is 32, and this is 2 raised to the power 3, which is 8, will be equal to 40. Now let's say I want to shift 10 towards left by 3. So what I'll do, keep moving all these bits towards left. Here 0, this 0 will come over here, this 0 will be shifted over here, this is over here, this is 1, I'm sorry, this is 1, this 0 will be shifted over here, this 1 will be shifted over here, this 0 will be shifted over here. So now if you can see, this is 2 raised to the power 6, which is 64, and this is 2 raised to the power 4, which is 16, which becomes 80. 64 plus 16 is 80. Similarly, if we shift all these numbers, this one will be over here. This is 0. This is 1. All these are zeros. So now add these numbers. This one plus this one. This is 128 plus 32. It will be 160. So now let's say I want to move A towards left n times. So what will be my output? So if you can see over here 10. So 10, can I say this is 10 into 2 raised to the power 0? This is 20. 10 into 2 raised to the power 1. This is 40. 10 into 2 raised to the power 2. 10 into 2 raised to the power 3. It will be 80. 10 into 2 raised to the power 4. It will be 160, up to 10 into 2 raised to the power n. So what is our 10 over here? This 10 is our A. Can I say 10 into 2 raised to the power 0 will be 10. A into 2 raised to the power 1 will be 20. A into 2 raised to the power 2 will be 40. A into 2 raised to the power 3 will be 80. A into 2 raised to the power 4 will be 160, and similarly if we keep going, then it will be A into 2 raised to the power n. So which gives us an idea of finding a generalized formula. Means if we left shift a number by n, it will be A into 2 raised to the power n. So this is our generalized formula. So let's do a quick dry run. Let's say I want to shift A 4 times towards left where A is 10. So now let's replace A by 10 and N by 4. So what it will be? It will be 10 into 2 raised to the power 4, which is 10 into 16, which gives us 160. That means shifting A towards left 4 times, keeping A is equal to 10, will give us 160, and we have got 160 from here. So let's see it in VS Code. Let's say A is equal to 10 and B is equal to 4, and I want to shift 10 towards left 4 times. What should be my output? It should be 160. So here we go. And what if we have to shift 10 by 3 towards left? We should get 80 as an output. So here we go. So this is how left shift operators works. So you always have to remember this formula, how we can get the value when we are shifting any number towards left. So let's talk about the right shift operator. So similarly, as we done in the left shift operator, so we are just shifting our operator towards right. Instead of left, we will move towards right. So we know the binary representation for 20 will be 1 0 1 0 0. So 8 bits replace rest of the bits with 0. So now what we are doing, so we are getting nothing over here. So let's shift all these bits. 0, 0, 0, 1, 0, 1 and 0 over here. This is our 20, and this is 2 raised to the power 3 is 8, and this is 2 raised to the power 1 2. 8 plus 2 is equal to 10. Now again, right shift all these operators. This is 0, this will be 0, this will be 0, this will be 0. This is 0, this 1 will come over here, this 0 will come over here, 1 will come over here, and it goes out of space. So what this value is, 2 raised to the power 2 is equal to 4, and 2 raised to the power 0 is 1, so it is 5. Similarly, if we go for the next, it will be 0, 0, 0, 0, 0. This is 1, 0. So this value is 2 over here. And again, if you go for 4, this one will be shifted over here, and rest all will be replaced by 0, and final value is 1. 20 means, can I say this is 20 divided by 2 raised to the power 0? 20 divided by 2 raised to the power 1? 20 divided by 2 raised to the power 2? 20 divided by 2 raised to the power 3? 20 divided by 2 raised to the power 4. So 20 divided by 2 raised to the power 0, which means 20 divided by 1 will give us 20. 20 divided by 2 will give us 10. 20 divided by 4 will give us 2, and so on up to 20 into 2 raised to the power n. So can I say that if I right shift a number by n, then it will give me a into 2 raised to the power n, which means a right shifting n will give us a into 2 raised to the power n. Let's do a quick try run. Let's do for 10 and 3. So if we replace 10 by a by 10 and 2 raised to the power 3, which is 10 into 10 divided by 8, 8 ones are 8, and it will give us 1. So dividing 10, shifting 10 towards right by 3 should give us 1. And let's do it for 20 and 4. 20 and 4. So what should be our output? So from this formula, we can easily say that replacing a by 20 and n by 4, which is 2 raised to the power 4, which becomes 20 divided by 16, which will give us 16 point something. And being an integer value, fractions value will be discarded, so we will get 1. And let's try to execute it. So we got 1 over here. So this is how left shift and right shift operator works. So what you have to do, just remember this formula for right shifting a number n times, and remember this formula for left shifting a number n time.